Hello everyone, welcome back to the next video. This is Unit 6, Lesson 2. We're going to continue talking about exponents in this lesson. The iXL code associated with this lesson is 7SS. After you're done with the video, please look this up on iXL and complete your assignment. For this lesson, you will need some paper and some sort of writing utensil. I will be asking you to do a few example problems with me just to prove to me and to prove to yourself that you know what you are doing. Also, I do not want you to use a calculator for this lesson. I need you to try to work this out by hand, because if you're able to do it by hand, you truly understand what you are doing. So again, for this lesson, please do not use a calculator. Let's go ahead and get started. So here's our first example. Here we're being asked to evaluate the fraction 3 over 4 to the power of 2. So instead of working with whole numbers like we did in the last lesson, so for example, last lesson we did something like 3 to the power of 2 or 4 to the power of 3. We talked about what it means to have something inside the parentheses with an exponent on the outside and the difference when it doesn't have a parentheses. So let's look at the one that does have parentheses, because here our example has parentheses. So for this example right here, 3 to the power of 2, what we talked about in the last lesson was that if we have an exponent that's attached to something with a parentheses, everything that's on the inside, everything that's on the inside of that parentheses is going to be multiplied by itself. So in this case, because it's just 3, this means that we have 3 times 3. You could put it with parentheses if you want, because technically this 3 is inside of a parentheses and it is being multiplied by itself. But because it's just a regular number, you don't have to. So now let's use this example and let's apply it to the example problem that we're actually given. So in a very similar way, and let's get rid of this as well. Here we have something inside the parentheses. So we're going to be multiplying 3 over 4 times itself 2 times, because that's what our exponent here tells us. We have what's inside the parentheses and we're multiplying it by itself 2 times. That's all we have to do. We're just multiplying two fractions together. If you need a reminder on how to multiply fractions together, well, again, like we said in the other example, we technically don't need these parentheses. We're just multiplying two fractions together. And in this case, we're going to be multiplying straight across. So we're going to be multiplying our numerators together and our denominators together. So 3 times 3 is 9, and 4 times 4 is 16. So, looking back at our original problem, the fraction 3 over 4 to the power of 2 is the same thing as saying 9 over 16. We're going to be doing the same thing with this next example. Here we have the fraction 1 over 3 being raised to the power of 4. Just like in our previous example, we're just going to take what's inside of the fraction, which in this case is 1 over 3, and we're going to be multiplying it by itself 4 times. So here we have 1 over 3 times 1 over 3 times 1 over 3 times 1 over 3. We know that because of the exponent, it's 4. So now what we have to do is we're just trying to figure out what this is equal to. Again, I want you to do this by hand. I just want to make sure that you get the practice of working through problems like these by hand. Yes, it's technically easier with a calculator, but again, I need you to work this out by hand. Prove to me that you understand this. So I'm going to try to do this the fastest way that I know how. There's different ways that you could do this. Whenever we're multiplying fractions, we're just multiplying the numerators across and the denominators across. So here we have 1 times 1 times 1 times 1. Well, 1 times itself is the same thing as just saying 1. And in the denominator, we have 3 times 3, which is 9. And instead of multiplying this 9 by 3, I want to speed up my process. I think that for me, it's actually easier to go over here and multiply this 3 times 3, which gives me 9. And then now I have 9 times 9, which gives me 81. To me, that's a little faster. You could do this any way you want as long as you're multiplying that correctly. So 3 times 3 times 3 times 3 is equal to 81. So again, that means that 1 over 3 to the power of 4 is equal to 1 over 81. Now it's your turn. Here you have the fraction 2 over 5 being raised to the power of 3. Please work this out by hand. Do not use a calculator. If you need to do any multiplication, please do it out by hand. You have a minute. Go ahead and get started. That was 1 minute. Let's go ahead and talk about this problem together. So here we have the fraction inside the parentheses 2 over 5, and all of that is being raised to the power of 3. Again, because we have the 3 being attached to everything that's inside the parentheses, we should have the fraction 2 over 5 being multiplied by itself 3 times. So here we have 2 over 5 times 2 over 5 times 2 over 5. Well, again, we're just going to be multiplying fractions. We're going to multiply the numerators on top and then the denominators at the bottom. So here we have, and let me change the color here real quick. We have 2 times 2, which gives us 4. And now we have 4 times 2, which gives us 8. So 2 times 2 times 2 is 8. In our denominator, we have 5 times 5, which is 25. 5 times another 5, well, that should give me 125. If you need to work that out, please do that by hand. Try not to use a calculator. So here, our final answer should be 8 over 125. There's actually something else I want to show you here before we move on to the next problem. So let's go ahead and erase this. Let's review this one more time. So we have 2 over 5 to the power of 3, which we just talked about is the same thing as saying 2 over 5 times 2 over 5 times 2 over 5. Well, yes, we know that 2 times 2 times 2 is 8. We just said that. But there's actually another way that you could write this out with exponents. So here we have 2 times 2 times 2. What if I actually wanted to keep the exponent here? Well, 2 times 2 times 2, we know that our base, the number that's being multiplied by itself, is 2. And the number of times that it's being multiplied by itself is 3 times. So we should have an exponent of 3. Same thing at the bottom. Here we see 5 being multiplied by itself 3 times. So this is 5 to the power of 3. So what do you notice from our original problem and what we just wrote down right here? Well, whenever you have a fraction and you have an exponent on the outside, technically that number, in this case the numerator and the denominator, it's the same thing as kind of just like attaching the exponent from the outside to the inside. It's a little more complicated, and yes, it works for this example. So again, here it's just 2 to the power of 3 as we saw over here on the right side, and at the bottom it's 5 to the power of 3. But there's actually a little bit more happening, and we're going to be talking about that in another episode. But before we start talking about other fraction examples, let's actually talk about decimals. Nothing changes. The same thinking applies for this problem as well. But the main reason I want to review this with you is because I know that multiplying decimals has been a while for most of us. So I want to make sure that we get a chance to review this skill just to make sure that you're able to do it without a calculator. We're going to be doing all of this by hand. This problem is asking us to evaluate 0.3 to the power of 2. Same as before, we know that this exponent, because it's attached to the parentheses, it's asking us to multiply everything inside the parentheses by itself 2 times. This is 0.3 times 0.3. To multiply this out, I'm going to stack them on top of each other. And let's just go ahead and multiply this out. 3 times 3 is 9. 3 times 0 is 0. Because we just moved to a new place value, we need to fill this spot with something. I'm going to put a 0 here. You could put an X, depending on how you learned it. You might put something different, but a 0 is fine for now. So 0 times 3 is 0. 0 times 0 is 0. We're going to add this up together. 9 plus 0 is 9. 0 plus 0 is 0. And then the 0 is by itself, so it just stays there by itself. Let's go ahead and pull this out to the side just so we have a little bit more more space to work. Now the question is, where does the decimal go? In order to figure that out, we need to look back at decimals in the original problem. The decimals that I'm talking about are right here. These two decimals. We're going to start with this first decimal and we're just going to move it over 1 unit. We're going to do the same thing with the 1 at the bottom. So in total, we moved a total of 2 spaces. For our final answer, we're going to start here at the end of 9. And because we counted a total of 2 spaces, we're going to move to the left 2 spaces as well. 1, 2. This is where the decimal ends up, which means that our final answer, 0.3 to the power of 2, is 0.09. That's it. Here's a slightly harder problem. Here we have 0.12 inside parentheses being raised to the power of 3. Same as before, we're going to take what's inside of our parentheses and we're going to be multiplying that out by itself. In this case, 3 times because that is our exponent. So here we have 0.12 times 0.12 times 0.12. We're going to start off by multiplying these first 2 numbers. I'm going to work this out on the side. We have 2 times 2, which is 4, 2 times 1, which is 2, and then we have 2 times 0, which is 0. Let's move on to the 1. Again, we need to put something down here, an X, a 0, something to take up that place value because we moved over 1 place value as well. Let's multiply 1 times 2, which is 2, 1 times 1, which is 1, and then 1 times 0, which is 0. Our last number is 0, which is just going to give us 0 as our answer. Let's go ahead and add all this up. 4, 4, 1, 0, 0. Now we're going to go back here and just count the decimal spaces to the right. Let's start with this decimal space. We're going to count 1, 2 spaces to the right, and then we're going to do the same thing down here, which is also 2 spaces. So in total, I moved a total of 4 spaces, 4 place values. We're going to go down to our answer, we're going to put a decimal at the end, and we're going to count a total of 4 spaces to the left. 1, 2, 3, 4. That means that the first part of our answer is 0.0144, but we're not done. We still have to multiply that number with 0.12. Again, we've only multiplied the first 2 numbers right here. We still have to take care of that third one right here. I'm going to work it out here on the side, on the top right. So I'm going to start with my big number. I just want to start with my big number. It usually helps make sure that your work is a little easier. And then I'm going to put the number at the bottom. I'm actually going to write it like this. So 2, 1, 0, and the decimal is going to go here. For multiplication, you don't have to line up your decimals. Again, the way we use the decimals is at the end when we do the counting, like we did in the other example. So let's go ahead and multiply this out. 2 times 4 is 8. 2 times 4 again is 8. 2 times 1 is 2. And then 0 and 0. We're going to go down here, put a 0 as well. And now we have 1 times 4 is 4. 1 times 4 is 4. 1 times 1 is 1. And then we have zeros. And then at the end, we're going to multiply the 0. In this case, I'm actually not going to multiply it out because it's not going to change our answer. I'm just going to go down here and add this last part. We have, and I'm going to write it down this way. We have 8. 4 plus 8 is 12, so 2 carry the 1. 4 plus 2 is 6, plus 1 is 7, and then 1 plus 0 is 1, 0, 0. Same as before, I'm going to count my decimal places. So here's my decimal, 1, 2, 3, 4 spaces, and then 1, 2. So 4 up here, 2 down here, so that means that we have a total of 6 spaces that we moved. I'm going to go down here to my answer, and I'm going to move 6 spaces. 1, 2, 3, 4, 5, 6. So our final answer is 0.001728. Here's your practice problem. You have a minute to try this out. Again, please do this by hand. Do not use a calculator. If you feel like you need a little bit more time, go ahead and pause the video and then play when you are ready to go. Your time starts now. That was 1 minute. Let's go ahead and review the problem together. As you can see, we have the problem written down here twice. That's actually because there's 2 ways that I want you to think about doing this problem out. We have 0.04 being multiplied by itself 4 times because of that exponent. So this is 0.04 times 0.04 times 0.04 times 0.04. So we have a bunch of multiplication that we have to take care of. We might run out of space, but let's go ahead and work this out. We have 0.04 times 0.04. 4 times 4 is 16. Carry the 1, put the 6 down here. 4 times 0 is 0, plus 1 is 1, and then 4 times 0 is 0. The next numbers are zeros. I'm actually not going to work them out because they're actually not going to change our final answer. So here we could actually just skip to the decimal part. I'm going to count my decimals. I start right here. Let's move 1, 2, and same thing down here, 1, 2. So that's a total of 4 spaces. Let's start here at the end, 1, 2, 3, and 4. In this empty space, we're just going to put a 0, and our decimal is going to be here at the end. 0.04 times 0.04 turns out to be 0.0016. Now we're going to multiply that out with this one, and then we're going to multiply our answer with this final 0.04. But there's actually another way to do it. If you did it this way, that is totally fine. That's the way that we reviewed. That is correct. But again, we're trying to save a little bit of time. We still don't want to use a calculator, but let's look at a different way to think about the last part instead of having to multiply 1 by 1. Let's write this out one more time. We have 0.04 times 0.04 times 0.04 times 0.04. We already did the work for the first part. We know that this is equal to 0.0016. Instead of doing what we talked about on the left, we already know that 0.04 is also 0.0016. When you work this out by hand, your answer should be 0.000000256, which should be the same answer that you would have gotten if you did it the other way. And that's it. Your assignment for today is going to be code 7SS on iXL. As always, your goal is to get at least a 70 to prove to me and to prove to yourself that you have a basic understanding of what we just talked about in this lesson. And if you want to push yourself, if you want to prove to me that you really understand this, you're trying to aim for something a little higher, somewhere in the 80s, 90s, or even a 100 if you want to.